coterminal angles. So a lot of times, we'll call this the terminal arm of some circle or whatever. Okay, this will be our circle. Any coordinate, like we said, can be kind of fit to a circle that starts at the origin. So this is our arm, and they're going to ask us for some angle. We don't know which angle. It could be this one here, which is pretty simple. Our angles usually start from the x-axis, and think of it from the positive side. So when we're talking about an angle, this would be theta when we're going around the arm. Think of it like the arm of the circle starts down here and then opens up to this point here. So that's our angle of theta. Okay, and they'll probably give you some coordinate, whatever the coordinate is. X is positive, y is positive. So that's how you kind of fill it in as you go along. So this one's pretty simple because anything from here up to the y-axis is within 90 degrees, which is stuff we're pretty simple. We're used to solving those ideas. But as soon as the coterminal angle goes outside of that, so these are all what they would consider acute angles. So everything red will be acute. As soon as we're outside of that into here, now we're into what they would consider like the obtuse range of an angle. So obtuse angles are greater than 90 but less than 180. So maybe we should keep that one as the first. Actually, no, we'll just move the arm around. Now it depends. So when finding an obtuse angle, let's say this is our theta here. If they want us to find this theta, we can kind of go about what we've done before, where we can create a right angle triangle and talk about this being y and x and r and setting up either sine, cosine, or tangent to solve. But what if they're talking about this angle here? Well, we can try to set up a triangle like this, but then we already don't know the radius and we don't really know how far this is. It would actually be the radius again. We have to use some kind of sine law or cosine law. So it's actually easier if we do the exact same idea. And what that same idea would be is that we're just going to create, again, a right angle triangle. Okay. So we create our right angle triangle. We solve for this angle. And since we know that this point would be 180 degrees away from where we started, think of this starting point as 0 degrees. Okay? This is our 90 degrees. So we know that this would be 180 degrees. We can then solve for any of these obtuse angles. Okay, we'll draw them in green. Any obtuse angle here would be 180 degrees, okay, minus theta. Okay, and we'll call this, have you ever seen like beta or something else written? We'll call this angle here angle beta. Okay, so this angle, this obtuse angle here, can be found by taking 180 degrees and subtracting the theta. Okay, because we know all the way there, think of it like we've taken the terminal arm all the way around, and then we went a little too far, so we come back a bit. So once we figure out what that angle is, we know how much we need to come back, and that will tell us how far this is. Okay. So then we use that same concept as we go into other quadrants. And again, the coordinates in this quadrant, you have to keep in mind that your x is going to be a negative coordinate and your y will be a positive coordinate. The next value is 270. So as we take the coterminal angle around again, maybe we'll draw, we'll say that this was our first coordinate, this was our second coordinate we found. As we take this arm around the circle again, okay, now we're in the range of something greater than 180 or less than 270. So there's a couple things we can do about here. And I didn't talk about it in the last one, but we'll show another one. Let's say blue. Okay, so let's say they want to know, there's quite a few angles they could ask for. Let's say they want to know from the beginning all the way around to here. Okay. Well, from this point, we're, again, going to set up the same idea. We set up a right angle triangle from our coordinate, okay? And we, like we normally do, we solve for this angle in here. But that angle in there really doesn't give us enough information. What we can do is we can solve for that angle there, and then because we started from 180 and then we're going past that by whatever that angle is, this idea would be 180 degrees plus theta would be, I've got to give this, what is it? Mu? This is called mu, something like that. I'm just trying to think of all the Greek letters. I don't know so many. Okay, so that would be another angle, another, we'll call that at angle there. So it comes around. We know it's greater than 180, but it's less than 270. So one of the ways you can solve that is the 180 plus what you found. Another way you could tactically find it is by going back 180 and then this way again. You could think you're at 270, and if you find out what this angle is, you subtract that from 270. So there's lots of different options. Usually what I do is I try to keep the same tactic as I go. So I like this working with 180 degrees and from 0 or 360. I don't tend to work too much from 270, 90, but you obviously can. Like in this angle here, if we had found out what this theta was instead, okay, and because it's 90, once you find this, you can subtract from 90 and find that, you could have taken 90 and added this to it, and that would have told you the exact same idea for the green one. So there's lots of different ways to do it. And then again, the final one to kind of look at is if you have a coordinate in this area, that's going to have positive x and negative y. Okay, so we have we have in that area. As we come around, same concept. Build a right angle triangle. Right color here, orange. There we are. Build a right angle triangle. This is the theta we use. And you can add from 270 if you figure out this unknown one here. I'll tend to take 360 degrees, okay, and subtract from it. Yeah, so whatever that is, this theta, I know I called it, or no, I gotta give it a new name. What other Greek letters I know? Let's just call it x. We'll say that this is the huge angle coming around here is x. X would be equal to 360 degrees, subtract whatever that theta is that we found in that case. Okay, so that would be the concepts around. And then once they're talking about coterminal, okay, so this is how to find anything under 360. Once you're talking about coterminal, where they tell you got to make several movements around, like so maybe you make 2 rotations one way, all you're doing is adding 360 degrees to any of these angles that you've already solved, and including the 90-degree one. So think about it. If they tell you you go around 1, 2 times, okay, just focus on this arm here and finding it. And then once you have your answer, you would add 360 degrees to that answer. Because one rotation, because this is a circle, one rotation is 360. So we don't really have to worry about, okay, I go around 360 and then, okay, this is going to be 570. Just focus on within 360 where our angle stops, and then you just add 360 to your answer at the end there.
Okay.
And then, of course, these are all counterclockwise. You can do the opposite way. And the opposite way is exact same concepts for finding out from adding from 180 or subtracting. You're just going backwards. They consider it a negative value when you go the other way. So everything would be negative going back around.